So I'll introduce Andy and Mike. So we've got Andy Gillis, and he's been involved with COMED from its inception. Andy is a former BOHS president and regular presenter at conferences and regional workshops. He has been an advocate of practical, effective exposure controls throughout his career. And we've got Mike Perry as well, who's also a former BOHS examiner and joined COMED, the COMED management team last year. Mike is an occupational hygiene consultant specialising in pharmaceutical potent compound safety. His work includes evaluating the performance capability of containment equipment to nanogram levels and developing procedures for the optimization of specialist engineering controls. So I'll pass you over to Andy and Mike. Thank you.
Thank you, Helen.
Thanks, Helen. I'll just bring up the slides. Well, I'd like to welcome everybody to this online workshop on the Control Measures Efficiency Database, or COMED. We're delighted that you've taken the time to find out a little bit more about COMED, and we hope you'll find the workshop this morning informative and interesting. Please note that COMED is a work in progress. We're currently refining and developing the draft database, and COMED has not yet been made publicly available. So today what you're being shown is a snapshot of the current state of play and an illustration of the main features of the database. As well as making you a little bit more familiar with COMED and giving you the opportunity to have some hands-on practice with it, we're also very keen to gain feedback from everybody about your opinions of COMED as it stands at the moment. You should have received, together with the registration link that BOHS sent out, a couple of attachments. One, a case study answer sheet, which we'll be using later on in the program when we get to the practical case study examples. And a second document, a delegate feedback form. And we'd like to ask all of you to complete the feedback form and return it electronically to the email address we'll show you at the end of the presentation. Here is the agenda of what we intend to go through this morning. Mike and I will swap between the different sections so you don't get bored with hearing one voice all the time. We'll use a few slides to begin with. We want to focus on the practical examples and give you plenty of time to get your hands onto the database and play around with it. And as Helen said, if anybody has not yet registered and been able to access the COMED database, then please try and do so now. And if you have any issues, any problems, just raise your hand and enter the chat box and we'll see if we can help sort that out. Our vision for COMED is shown on this slide. We really see COMED as being the premier database for good quality, reliable, objective data on the efficiency of exposure control measures, quantified efficiency data. This is something that is really lacking in the occupational hygiene world in many respects at the moment, and it's a gap that needs to be filled. COMED is the product of a unique collaboration between a renowned academic institute, the Fraunhofer-ITEM Institute in Hanover in Germany, BOHS, the leading occupational hygiene professional body based here in the UK, and a learned society for people interested in occupational health in the widest sense, and individual practitioners like Mike and myself who've been involved from the early days of the development of COMED. This next slide shows you some of the key features that the database provides. We hope that COMED will offer a one-stop shop for relevant information and data on control measures efficiency and the applications of common control measures in many different industries. The tool has been designed with the input of qualified practicing occupational hygienists right from the outset. So we hope that what we've developed is a scientifically robust but also very practical take on selecting and using to best effect the common controls that we all know about. A little bit of background in terms of how the idea for COMED arose. This all began with a series of workshops that were run at BOHS annual conferences and regional meetings by myself and my professional colleague and friend Alvin Woolley. And the first of these workshops was held at the International Occupational Hygiene Association annual meeting in London back in 2015. And what we did with a room that was packed with experienced professional occupational hygienists and exposure assessment professionals was split them up into teams, small groups, and present them with scenarios, real world scenarios where we had exposure data from before and after the implementation of control measures. And we asked some simple questions to get their estimate of how much exposure would be reduced by if a certain control measure was applied. And the results were startling. We got orders of magnitude difference in estimated exposure reductions from different teams, and similarly great differences between the estimated reductions and the actual measured data from the scenarios. So it was apparent that use of professional judgment and personal experience varied widely, and there was a big gap in terms of published efficiency data on effective control measures. So BOHS agreed to set up a working group the following year, which submitted its final report to the Society in the summer of 2019. And from September 2019, the Fraunhofer Item Institute took over the leadership of the ongoing and future development of the database. The structure and organization behind COMED as we currently have it is shown in this slide. So a management group coordinates the work of three main executive working teams. The first, which is led by myself, is a team of volunteers, individual volunteers who contribute in many different ways, for example, in entering individual data sets onto the database, either from published literature or their own experience, evaluating existing data sets, and many other ways. A second team led by Mike, which looks at validation, which in our terms addresses issues of data quality and the control advice sheets, of which we'll talk a little bit about in the future, and the database development working team, which looks at the development and maintenance of the database. I'll now ask Mike to take over and talk about the key elements of the database.
Right. Thank you, Andy. Thank you for that. I'm going to open my share screen so that I can take control of the slides. Desktop, here we go. That's not the one. Where are my slides? Here we are. Oops. Excuse me, I'm not in the right position. Sorry about this. Here we go. So key elements of COMED. This is where we're starting. Right. So the idea of these few slides that I'm going to show you now is just to show you how the information flows through the database. So don't get too worried about what we're seeing here. It's just to kind of illustrate. So maybe when use the software, it will kind of make a little bit more sense how it's all operating. So from the database point of view, we have data sets. Now these are sets of their studies. They come, like Andy's already said, they've come from various sources, and we'll be discussing them more a bit later on. But they could be workplace, they could be scientific studies, laboratory settings, various, or they could be review papers and so on. But one thing they all have in common is that they all produce, each of these data sets produce an output of an efficiency value, an efficiency percentage reduction. Okay, so they'll produce one value which then flows into the queries. So we can now question this data. The data sets are kind of categorized in terms of the control measure you're interested in and the type of process involved. So having made those selections, then you come through to the queries section, where having made this your query, all the data is analyzed, or just some of the data is analyzed based on further selections or kind of filtering criteria and so on. So the analysis outputs then come out and are displayed in a PDF report to make it easy to look at, along with what we call the efficiency ladder ratings, ratings ladder. So that's kind of to provide easy cross-reference between different options that you have. And then from the PDF report, we then have controlled advice sheets, which either stand alone or are linked. We haven't quite worked out exactly how they're going to be linked to the PDF report. So this is again another printable kind of document which provides information about the pros and cons of the advice sheets. Okay, so I've already spoken a little bit about the data sets, and just to remind you here, they're coming from published and unpublished sources, laboratory studies, workplace assessments, review papers, and so on. As far as review papers are concerned, we need to split them up, and we'll see an example of that later today. In other words, a review paper may come up with a number of different scenarios producing different efficiency values. So part of the job of the initial putting this data into the system is to review those papers, break them up, and see what values can come out that are useful as individual efficiency data numbers which can flow into this system. Now, when you get into the queries section, you're going to have the opportunity to see all the data that's been generated by your first selection, or as I said before, you'll be able to make further selections. In other words, you might be able to, you can choose a threshold of efficiency value that you're interested. You can select either good, fair, or poor, or a combination of these if you like, or you can go work by a year if you only want to see a certain range over time. So whatever happens, these two are compared side by side, and then these are displayed in the PDF report, as I said before. So the analysis that's performed when you get to this this stage will show you. I'll try and I'll expand this up a little bit. Okay, I know it won't expand. Okay, the bar graphs here. These are all the individual data sets showing the efficiencies. Here's 0 to 100 here. So you see the full range there. They're also displayed in terms of these these ranges. Like this is less than 50%. This is 50 to 75%. This is 75 to 90. This is 90 to 95, and this is greater than 95. So it's a non-linear split in terms of the efficiency. So that's something that was decided right at the outset. But again, is not completely fixed in stone for when it comes to sort of some other later considerations which we're talking about. So also here you'll see standard deviation is displayed plus the range of the data. So this is for the select data here, and further down you'll be seeing all the data as well. Okay, so with the efficiency ladder, ratings ladder, those criteria I mentioned to you a minute ago, the greater than 95% being related to A on this scale. So the idea and the presentation of this comes from the kind of European white goods efficiency in the environmental standards for white goods equipment. So we were thinking, this would provide an easy way of comparing the efficiency of different data, and there's an adapted efficiency which is built into this. So if the data is weak for either in the terms of the number of the data sets available to make it up, or the standard deviation is high, then we have a system which knocks it down by 1 rating. Okay. Robustness rating is work in progress. It will appear here as well in the efficiency ladder. And we're going to probably split this up into 2 factors: the technical side of things, like how reliable is the control measure from a day-to-day basis, what sort of maintenance is required, and also the human factors is kind of how easy it is for people to work with, or the chances of them using it correctly every time. The controlled advice sheets are the last stage, as I said before, and here it's a summary of all the information that we think is useful to you when you are considering this control measure. And we'll be looking at a bit more detail later on. Okay. Here we're just going to mention our volunteer network. Andy mentioned earlier you will have had a feedback form, and it would be lovely if you could have a look at that, and if those of you who'd like to get a bit involved with us and would like to be added to our list of volunteers, these are the sort of areas that you can help in. So the form, you will find you can tick any of the boxes which relate to these areas of your specific interest, and you can join us and help build it. Okay. So now I'm going to switch to the COMED demonstration. I need to find. Here we go. Is everyone? You can see that, Andy? Yeah.
Yeah.
Right. Okay. Here's the opening screen, which many of you have probably already seen anyway. So we have 4 basic drop-down menus to select from. The first home page provides information about the background to COMED, our sponsors and links, and also there will be the user guide. These are not developed yet, so I'm not going to show you those. With the second tab, we've got data entry. In fact, it's just data generally. So if I open the data set here, we'll see all the data sets that are currently in the system. Okay, they're all listed here. So if we're interested in, say, for example, grinding, we're going to start with that. Oh no, actually that's welding. I was interested. Here we go. So if I search now, you'll see that they're highlighted, the ones that come under welding. So I'm going to go to the one of Andy's entries, which is quite a recent one. If I just select that and open it, now we see this is what comprises one data set. So this is basically a summary of the paper that has been reviewed, or in this case, Andy's own report, really. Okay, so he said it's an unpublished industry data. In this work in process box, we've got the information about the process itself. You can see welding. He was able to select the process, also the subcategory of a process, in this case MIG-MAG. These 2 boxes relate to the requirements of reach and so on. I'm not going to spend time on those. Here we have an exposure time, so 15 minutes up to 60 minutes or beyond. You can select all this information. Also the material you're handling and the hazardous substances involved. Okay. Here it's just generally welding fumes. He can add additional information as he has here. Now, in the contextual information section, this provides information about the type of study that it was, the design, intervention study, expert judgment, and so on. Data Data type, in this case, it's personal samples. There could be static samples, or could be a combination of both. And here an opportunity to describe the measurement technique, not in any huge detail, but enough that we know what's been done and what the reference of the method is. Further information is available as a box to fill in as you wish. Okay, so here's Andy's information here, and on the other side, here's the technical data, the information related to the actual tool he was using. I don't need to say too much about that, it's very self-explanatory. And here is the critical box. This is the results data, the numbers that actually come out. So here Andy has given us, I believe, an average of the control measure with it off. In other words, the before value, 2.9. And here's the value with the control measure on, 0.6. So in this case, that relates to a reduction, a percentage reduction of 79%. Okay, it's 79% lower than it was before we applied the control measure. And here in dataset reliability, Andy's rated himself good. Of course, we would expect that from Andy, but we don't have any criteria to actually decide good, medium, and poor, and that's something we're going to look at later on and have a little discussion about, because there is no system as such for choosing good, medium, or poor. And it does have quite a bearing on the outputs that come out of COMED. Okay, so that's that page. That's all that's involved here. If you were able to enter a new data set, as some users will be able to, this is where they would do it. So if I move on to the analysis tab, we're now going to move to the actually doing a query and looking at some data. So I'm going to use grinding as an example. Sub-process will not be specified. This is an LEV control, and the subcategory will be on tool extraction. Okay. So if I do a search, it's now pulling up all the data sets based on that criteria. Okay, and there are 21 of them. So if I go straight to the analysis button, I can see the output of those 21 data sets. So here the efficiencies are all shown as a bar chart. This is how they pan out in terms of the groupings that I mentioned before. So we've got predominantly up here 90s to 95% efficiency. Okay. Now, say for example, you want to dig a bit deeper, or you want to be more specific about your search. I'm going to use, I'm going to say, okay, I only want to see data that's no more than 10 years old. That will exclude older data, which I might not trust so much, for example. So having ticked those, you see the boxes are now ticked. So if I run the analysis again, we now have two sets of data. We have the selected data. And we've now got 1, 2, 3, 4, 5, 6. We now have 10 data sets, which are all within the last 10 years. Okay, and we can now see that they're now more firmly based in the 90 to 95 brackets. Okay, compared to the all data, which is still shown here. So if I now go to the PDF report, this information is now shown. It takes a little while to pull up. Okay, here we go. This is now the efficiency ladder I mentioned before, and as you can see, I'll zoom in a little bit so you can see here. On the left side here, we have all data. So we had 21 data sets, efficiency mean of 90, which put it into category B with a standard deviation of 13.8. Now, when we selected the last 10 years data, the number of data sets is now 10 with an efficiency mean of 95. So we can see there, it's given us a visual output that we've got a better confidence now, having looked at the last 10 years of information. Standard deviation is now 3.3. Okay. If the number of data sets were to fall below 10, I believe the way it's working at the moment is that it would then knock down the adapted efficiency to B. Okay, so that is the sort of outputs that COMED is designed to give you. If you want to select manually these different surveys, you can open them up and have a look. They're there, so you can say, okay, that one, oh, that's also similar to what I'm working with. I'm going to include it. So once you've manually include these, you can then run the analysis again, and here you get. Now you've got more data sets, but we've got this one included here. Okay, so that's how that works. Now, the next thing to show you are the cache sheets. So if I open the cache sheet related to grinding, oh no, welding. Let's try welding because I know that's more complete. So if I open that one, here you will see the same sort of information coming through, a little bit more information to help your decision making. Again, the control advice sheet here is kind of, now this is kind of more of a standalone kind of rating for the control measure, as you see, based on quality good. So you still got this, you can't control this on the CAS output at the moment, but it might be possible in the future. Again, you have all the analysis information followed by all the references in a sort of report form, so that if you need to share that with anyone and then want to look at the reports, they can. So that kind of completes my demonstration of the software. Any comments at this point, Andy, about where we are with, can we move on to the case studies now?
I think move straight on to the case study, Mike, while that's still fresh.
Yeah, go straight on to that. Okay. So this is where we invite all of you to have a go at what I've just done. If I go back to PowerPoint presentation, we're going to start with the MIG welding on torch extraction, and then secondly we'll do a grinding one. This is the data that we have in the system at the moment that you all have access to. The first one is for MIG welding with on torch extraction. I've already described some of the the technical side from Andy's data sheet earlier. So we're looking at seeing what sort of reduction we're going to get from from applying on torch extraction. Okay, and these are the questions which on your answer sheet we'll be addressing once you've had a chance to play around. We'll get some feedback from you as to kind of whether this, by using the system, you'll be able to kind of make an evaluation as to whether it's a good, viable control option, and so on. So as you work, there's also some other questions on the data sheet, simple questions like how many data sets are there when you do certain searches, what the average efficiency is for all data, for example. So if you've got that sheet available and can jot down the answers, then we'll share and talk about them afterwards, and also your experience of using the software. Okay. Now, I'm not in the chat box here at the moment. Has everybody or the majority of people managed to get access to COMED? That's what we need to consider at the moment.
Perhaps ask for everyone to raise their hand if they have a problem.
Are we okay? I can't see that screen at the moment.
You've got 2 people raise their hands, Mike. Sorry, it's Helen. You've got
Okay.
2 on there that have raised their hands that have obviously, well, saying they've got a problem.
Okay. Right. Well,
3 now.
Okay. Well, if everyone would like to make a start on that, if you've not already started on it, we've got those 3 people then to entertain while this is going on.
4 now.
4, okay. What I can do is run through it with them, if that's one option. Would everyone like that? And the others can maybe mute their sound so they don't hear what I'm saying if they want to be left alone for a few minutes. Does that sound sensible?
Yes, except it might distract people who are working through the problem on their own. Maybe we could do a hypothetical study of another example.
For those guys who said they've got problems, if it just came back when you registered as and it's come back and it said failed, try putting your username and password in the box again, because it came back as failed for me, but it actually hasn't failed. You can still log on. So just try that.
Yeah, good idea, Helen.
Okay. On my system, I can show them something else, but it would be a bit random. Should we do that, Andy?
Yes, why don't we do that? Maybe pick out some other example from the welding data sets, perhaps.
Yeah. Or drilling. Is there any drilling or cutting info in the system that you can think of?
Not that I can think of. It's quite it's not been quality checked, so I'm not sure just what we've got in there.
Okay.
One other example could be look at water suppression for grinding.
Okay, let's do that. Grinding.
So you can just talk through, I guess, Mike, and people can follow.
There we go. I'm presuming those that haven't got access to COMED can see what I'm doing. If not, raise your hand. So Andy, maybe you can talk us through this one then.
Yeah, sure. So you may have followed Mike in the specification of his query at the top of the page there. So he selected grinding as the relevant process, and then under engineering control measure in the drop-down menu for that, he's picked up on water suppression. So then pressing the search button to the right pulls up all the relevant references under those two search terms, grinding and water suppression. So that shows you with a quick eyeball that we've got 2, 4, 6, we've got 9 data sets listed with efficiencies ranging from what seems to be 0 to 99.4%. Extraordinary. So if you have lots of references and it's difficult to count them all up, if you look above the analysis button, it actually shows you that 9 entries were found based on the search terms that you used. If Mike now presses on the analysis button, then those 9 data sets are shown in the histogram at the top. And each of the data sets has a unique data entry number. So the first reference that's listed is data set 105 and 106, 143, etc. And what is plotted on the histogram is the measured and quoted or calculated efficiency of the control measure, in this case water suppression when grinding. Now clearly lots of different grinding activities can be carried out in many different applications, many different industrial settings. So you may not be comparing in these 9 examples exactly the same application. So if you're looking at this as a particular challenge in your workplace, clearly what you need to do, having done this first search, is refer back to the original references and just check to see what application was being covered by the original references. But if we assume that they're all pretty similar and we're comparing apples with apples, then we've got 9 data sets there. And in the graph below the top graph, the green histogram, that shows this, this categorization that Mike's described before. And from a quick eyeballing of that, that tells me that the majority of data sets are showing that the efficiency of water suppression is at or above 95%. 6 of 9 data sets are showing you above 90%, 95%. So that gives me confidence that there's consistency in the findings. So I'm expecting water suppression to be pretty effective. So if we go back to the top of the page, Mike, if you can scroll back to the top.
Can you see me?
Yeah, the slide's not moving on my screen.
Should be.
Okay, we've frozen up just a little at the moment.
Moving now? Can you see?
Not yet. No, no. It's an intermittent problem, I think, because of the bandwidth that we need to run the database.
That's not so good. I'll turn my camera off.
Yeah, this one.
Has that helped?
No, still not moving.
Oh dear.
Yes, there we are. We're back in.
Okay.
So if people can see Mike's screen now, if you now select on the PDF report, Mike, the button at the top.
You got that?
No, no. Yes, it's coming up. It's just a bit slow to respond. So here we have the PDF report based on all 9 data sets, which shows you the mean efficiency of the 9 data set results with a standard deviation, and illustrates the ratings ladder pictogram that Mike had described previously. One thing I didn't mention, I should have done, if you can just go back to where we were originally, Mike, please, back to the database. If you look above the histogram with all the red blocks, you can see that the average efficiency for all the selected data sets has been calculated for you and is shown as 85%, plus or minus 11.7% as a standard deviation, with a 25th and 75th percentile worked out for you. So that's a very quick way of arriving at the average efficiency. I think if we go back to the PDF report, it should come up in a moment.
Yeah.
Right. So here we have the efficiency that we were looking at before, and if you scroll down.
How far?
Down to page 2. So past the ratings ladder, we now have reproduced for you here the histograms that we were looking at on the analysis page on the data set, and a list of all the relevant references that these data sets have been derived from. So it's a very quick way of pulling together relevant information on the particular control measuring application that we're interested in. And if you just go back to the data set again, right? The database again, sorry. And what we can further do is select based on the year of publication, as Mike shown before, or data quality. So could I ask you to select on medium data quality? And if you then press the filter button, this should show all the references that are categorized as medium. And in this case, it's every data set. In some cases, you would have data sets that are a mix of good, medium, and poor. So you can screen your analysis and focus in on the things that you're particularly interested in that way. Okay, hopefully that's been a useful demonstration for those of you who've not been able to access the database. So perhaps you can go back now, Mike, to the case study and go through the answers for everybody.
Okay, Andy, I can't see the chat box when I'm doing this, so could you handle that side of things? Now I'm showing this screen. Can you see the case study come up there?
Yes.
Okay. Right. So everybody, if you'd like to come back to us now, I think we'll just go through the answer sheet for welding. So if we work through the table first of all, from the query tab, having searched for welding MIG-MAG, how many data sets are there? This came out 46 for me. Is that right, Andy? With you? Does everyone agree with that? Just if you can enter into your chat box like a Y for yes, or N for no or something. I don't know. We might see a quick feedback on that. Anything coming up, Andy? Are you muted, Andy? I'm not hearing anybody at the moment.
Andy, Mike, yes. Lots of Y's, lots of yeses coming up. It's probably better just to ask people to use the icon and raise their hand.
Or they could type in the answer.
Yes.
Should we do that? So go to the second one. Okay, everyone type in the average efficiency, all data. You give me the nod, Andy, when you're happy and we move on. Are we getting 75.3, 73.5 coming up?
Yes, we are, Mike. It's the chat box is just covering my mute button, so I'll leave my microphone on.
Okay. So we better crack on. So how many entries came up when selecting good data? Oh, I can see it now, actually, so that's good. We've got 15s, loads of 15s, that's good. Okay, what about average efficiency now for the good data sets only? There seems to be a lot of agreement there. Is that what you get, Andy? 88.5?
Yeah.
And the adapted efficiency for selected data shown in the PDF report. Yeah, we're getting loads of agreement on C. That's great news. Okay, Right, we'll save the last question for the sort of more general discussion, but okay, so if we move on to the discussion, should we do that now, Andy, or come back to this after the grinding study?
I think just have the discussion on this case study first.
Yeah, okay, all right. So, so this first discussion question. So, if the exposure to manganese was 0.4, would the on-torch extraction be a viable control option? Should we have a yes or no vote on that? Some of you may have calculated what the exposure will come down to. Perhaps put that in. Okay. Okay, let's ask the second question. Has the efficiency and CAS information helped you reach an informed decision sufficiently you'd be trusting to go ahead with this? Let's have a yes or no on that. Yeah, we seem to be getting lots of agreements yes there. Now, okay, I thought for this one in, on a scale of 1 to 10, with 10 being the highest level of trust, to what extent would you trust the outputs that you've just found in COMED on a scale of 1 to 10, with 10 being the highest? Let's see what the feeling is. We've got 7 and mostly 7s, 8s. Okay, somebody's commented that the PDF data is different to the original reports. That's because the CAS is a standalone at the moment. It doesn't reflect the decisions you made. It's a standalone. Okay, we're getting a fair level of confidence there. 7s to 8s. Okay. Looking good. We've also got this question: what further information would be helpful when comparing on-torch extraction option with others that may be also under consideration? If anyone wants to type in a comment about that, we'll look at it. There's a query there about not being able to filter out good quality data. You'll be able to cover that again in the next case study. Cost, somebody's mentioned cost there. Yeah, we haven't got any figures on numbers for the economic side of things. Something that could potentially be added to the CAS sheet. Okay, well, there's no more comments coming in at the moment. So, Andy, do you want to hand over and do the grinding case study?
Yes, we'll do. Thanks, Mike.
I've stopped sharing now, so you should be able to. There's a question there: are these all task-based? Yes, it is all task-based monitoring. No, it's no 8-hour time-weighted average results. Although that is that correct? That is correct, Andy. We are not putting forward 8-hour time-weighted averages from the data sets into the system, correct?
That is correct. Yeah, in principle, we're just using task-based data at the moment. So hopefully everyone can view my my screen and the slides. Can you see that, Mike?
I can't.
Okay. Excuse me.
We've not got back to your slides yet, Andy.
No, okay. Need to do this. So you should be seeing my screen now. Is that not coming up?
Yes. Yeah, we got it now.
Okay, thank you. Right, a second case study, a little bit briefer than the welding case study that Mike's just gone through with you, but this will just help to bed in some of the things that Mike's explained. This case study is looking at the activity of restoration stoneworkers using 5-inch angle grinders, cutting and grinding and smoothing off silica-based stone material. So we're looking at respirable crystalline silica exposure. And this is work done by Catherine Healy and colleagues and was reported in the Annals in 2014. And it will actually refer to dataset entries 2 to 9 in the COMED database. This was a well-conducted field intervention study where 4 different commercially available on-tool shrouds fitted to stationary vacuum units were used on a 5-inch angle grinder, and some exposure measurements of both respirable dust and respirable crystalline silica were taken either without the shroud being used as a baseline or with one of the 4 different types of shrouds in use. And breathing zone measurements of both crystalline silica taken with a Higgins and dual cyclone, followed by X-ray diffraction analysis, and respirable dust measured by a calibrated TSI photometer were collected over tasks of 10 to 15 minutes. So if you all look at the case study answer sheet, and case study 2 relates to this grinding activity. So the answer sheet takes you through step by step with the steps we would like you to follow in using the COMED database. So the starting point is to use the query tab and search the database for grinding with on-tool extraction. So if we can spend no more than 3 or 4 minutes just going through those 6 steps on the case study answer sheet, and then I'll go through the answers with everyone after that time. Okay, I'll leave this slide up for everybody to remind you of what we're doing.
Helen's saying it's International Workers' Memorial Day. Should we have a minute silence at 11? It's 3 minutes.
Okay, that's a very good idea. So it's 11 o'clock. If we can all stop and pause for 1 minute in remembrance of International Workers' Day, and then after 1 minute, I'll come back with the answers to questions on the answer sheet.
Perfect. Somebody's a little bit stuck there, not finding welding data. We won't need the welding data at the moment, so hopefully just press on with the grinding data.
Okay, everybody, it's 11 o'clock, so may I invite us all to spend 1 minute just in remembrance of International Workers' Day. Okay, thank you, everyone. I'd now like to just share and go through the answers to the questions that were posed. So the first question was, how many data sets are there if you search grinding with on-tool extraction? Could you just enter the number that you found on the conversation box chat? Yeah, yes, people are signing in and coming up with the number. 21 was selected. That's fine. What was the average efficiency for all data that you discovered based on the database? You can enter that. The simplest way to find average efficiency for your selected data is to look above the histograms on the analysis button and read off the calculated average efficiency there.
Just a quick point there, Andy, that number doesn't update itself when you do the filtering. That point was made by someone in the chat there. So you have to count them manually when you've done a filter. I think that will be corrected in the future.
Yes, that's a good point. Okay. I'm not seeing entries from anyone. Ah, yes, sorry, that was my.
Yeah, loads of 90.2s coming up there.
Yeah, that's absolutely fine. It's very similar to what we did for the welding case study. How many data sets did you just screen for good data only? Yes, the point made about the data sets. Yeah, most people are finding 8 data sets who've done that screening very well. And the average efficiency of the good data sets compared to the old data, what was everybody's finding there? 94.9, yeah. Great, so that's a good illustration of how you can quickly zero in on what you're particularly focused on. Now, was everyone able to open the PDF report and figure out the adapted efficiency ladder rating? What did you find for that? Yes, everybody's coming up with category C. That's excellent. Well, thank you, everyone. You've obviously picked up on the use of the database very quickly, so that looks fine. I'll stop sharing my screen now and hand back to Mike to go through the general feedback and the data quality.
Okay. You see that, Andy?
Yes, that's fine, Mike.
Right. Should we invite some feedback on to that point before we move on to this, or should we do all that at the end?
There have been some questions coming in on the chat box, which we've been trying to deal with as we go along. There'll be others that we'll need to respond to at the end of the workshop and by the end of the week, I think. So probably just straight on to data quality.
Okay. All right then. As you will have seen, choosing the data quality can have the ratings for it, good, fair and poor, can have quite a big influence on the outcome and what you actually see coming out of the PDF report and so on. So how do we decide what's good, what's fair, what's poor? It is an important decision that we have to make. So I've just got one slide relating to this, and it's really as a question of just opening up a sort of discussion on this, really, because we haven't got a system yet to handle this. But I've listed here many of the factors we need to consider when we're looking at a data set, particularly the number and quantity type of data that's coming forward from it. And also the ratio of the data before to after control. So say, for example, we only have one data point, one personal sample before, but we have 4 or 5 or even 6 data points afterwards, we're only as good as that one result that we had before when we're looking at the reliability of that efficiency data output. So we need to kind of build some numbers into this. What's the minimum kind of acceptable that we would consider for a good result, for example, for a good outcome? Also, we need to consider the methods that's been used, the type of analysis that's been carried out, where the analysis has been done, what the setting was, what the physical properties of the hazard were, because there could be different sort of dustiness, and so that can affect the extent to which it's controlled. Competency and experience of the person, the sampling strategy, all those sorts of factors, and the contextual information, how much information has been provided, all of these things. If it falls down anywhere, do we knock it down? Do we knock it down from good to fair? What are the criteria going to be for that? And of course, with some of these data sets that we get, we want to include them, but there'll be probably quite a bit of information missing. So we might be having to kind of make a sort of professional judgment as to kind of whether it comes across as a sort of competent piece of work, and whether we are willing to trust the data that's come out of it. So ultimately, we want some consistency here. Those that are involved in making these judgments, we'd like them to be kind of coming up with the same outcome. So this is something that is work in progress, in which, with volunteers that would like to work with me and add to the list of those that are already helping me, we can talk about these issues and try and come up with a system that kind of works, which isn't too difficult to apply, but strikes the right balance between kind of a quantitative approach and professional judgment, for example. So please tick that box if that's the sort of an area that you're interested in looking at. Okay, and helping us with. So that's probably as much as I need to say about that at this stage. And so I think we're now moving on to the sort of more open discussion at the end, and we would invite people to put their hand up and speak about what they've seen today as well. That would be helpful from our point of view. So I think that's the end. I beg your pardon, I've forgotten my last few slides. These are about robustness of control as well. We also need to consider and form a judgment on the robustness of the control, how likely we are to achieve the expected efficiency on a day-to-day basis for that control measure. And as I mentioned before, that will involve technical aspects, human aspects, and we may try to apply a rating system as well. So in that final CAS report, you might see the rating system there shown as kind of A, B or C ratings. So again, that's a topic under discussion, and we'll try and find criteria to kind of fit A, B and C in that sense as well. So Andy, do you want to, I'll hand it over to you for, well, we're not going to wrap up yet. We're going to have this discussion. How much time we've got? It's 12 minutes past 11 as far as I can see. So
yeah, we've got another 10 minutes for discussion if
yeah.
you want to pick up on some points that have been flagged up, Mike. Perhaps I can start by just going through a couple of the points that have arisen on the chat box and the conversations as we've been going along. One that Paul van der Sant has just posted refers to RPE listed as a control measure, and Paul asked, does the database contain data on RPE effectiveness? Well, the way that we've handled this so far is that we've got a separate document which is accessed through a button on the analysis page that perhaps we can show you in a moment, that gives general information on RPE, effectiveness of RPE, different types, assigned protection factors, etc. So that is a general document which is accessed to complement and supplement the analysis that's done on the data separately. Another question was posed earlier on: is COMED free to access and use once it is made publicly available? And the answer is, our intention is to make the basic format of COMED freely available to anybody who wishes to use it, but that a premium version will also be available at a fee to more expert users and people who wish to have more detailed information about certain topics. So there'll be a two-tier level of access: a basic user and a premium version. But that, of course, will only be when the tool is ready to be made publicly available, which it isn't yet. So if anybody wishes to use COMED as part of a teaching syllabus or in any other way, our plea is just be patient and hold your horses for a little while until we've developed it to the point where we're happy that it can be publicly available. Data quality criteria has come up a couple of times, and Mike has just given you a quick flavour of where we're at with that. It's a really important topic area for us, and we're very anxious to get input from different people with experience and ideas in that front. There was a question posed about whether we had used and incorporated containment data that's been generated specifically in the pharmaceutical industry sector, and we're clearly very much aware of that. To date, that has not been done. Our focus with COMED initially has been primarily looking at welding as an activity and typical control measures such as on-torch extraction for welding. One of the reasons for that was to tie in the output of the COMED tool with the Breathe Freely manufacturing campaign run by BOHS as an additional benefit to people involved in welding activities. But it's certainly something that we will be looking at and hopefully incorporating in the future. Someone also asked about cost data, and I presume that was referring to the cost of buying and implementing and maintaining control measures. Very important consideration when you're looking at selecting suitable controls, of course, and that's something that I think is a really interesting point, something for us to consider, but at the moment it's not something we've built into the system. Mike, do you want to pick up on any other issues?
I noticed here there was Eleanor has mentioned about CLIMISH scoring system for toxicology, which might have some application, which it would be interesting to look at that, see how that works, and thank you for raising that. I wasn't aware of it myself. I haven't seen any other questions to respond to at the moment. What plans do you have to add new data sets over future years? It's an ongoing situation, that, and involving the volunteers, and Andy is leading that initiative, I would say. Is that right, Andy?
Yeah, perhaps I can add to that. We're continually adding data sets as time goes on. Some of those data sets are, the majority in fact, are taken from peer-reviewed published literature. Other data sets are contributed by individual practitioners who are using unpublished data, the so-called grey literature, from their own records that are made available in an anonymized fashion. So it's an ongoing process, and the more good quality data we introduce into the database, the more confidence we have in the output and the outcomes of the analysis procedure. Another interesting question has just come in from Adam Clark. Adam asks, is this tool just for inhalation exposures? At the moment it is. We haven't had the resources or the opportunity to look into dermal exposure or other routes of exposure. So we're focusing on inhalation as the primary routes of exposure, which indeed I think we all agree it is for most hazardous substances. Okay.
Can I pick up on a comment here from Peter? A question from Peter Marshall. He says, how will it adapt to LEV booths and barrier isolators, for example? It will work where we have data which shows before and after. That's how it's kind of designed. So in the pharma settings, we don't often collect information in the absence of, say, an isolator or outside of an LEV booth. But perhaps we could gather data from, perhaps where maybe additions to an LEV booth, a downflow booth, like the screen, for example, a mobile screen. We might well have data out there which tells us what the before and after, and then that can be put into this system, and we can get an efficiency reduction value coming from that sort of data. So it has more limited application unless we have this sort of before data, available to us. So yes, it can be used, and I'm kind of, in fact, we're looking for kind of industry leads and champions for different industries. So I'm looking at it from a sort of pharma perspective and see how we can use it moving forward for that. And there might be other industries, other people out there can see potential for it. And if you, again, part of the volunteer thing, if you'd like to come forward and kind of represent your industry, let us know. That'd be great.
Okay, thanks, Mike. More questions are coming in, but we're running up to the deadline for the workshop, unfortunately. So the questions we haven't managed to deal with satisfactorily now, we will be looking at all of the questions and responding to them through an email that will be delivered to all attendees through the BOHS admin team by the end of the week. So if I can just share my screen again.
I'll stop mine, Andy. There you go. Okay.
Okay, excuse me. Okay. So to try and pull this together and summarize the situation, we believe that COMED is a valuable tool in the toolkit of occupational hygienists and other people involved in considering selection and use of many common control measures in many different industrial settings and workplace environments. And it has the potential to really help in driving down exposure to hazardous substances, in ensuring that the best, most appropriate control measures are used in different situations, and hence reducing the massive toll of ill health and disease and death that people suffer from the work that they do. So we are really great enthusiasts for this tool. We hope you found the workshop really interesting, and it's giving you a much better understanding and familiarity with what we're trying to achieve with COMED. If anybody is interested in supporting the development of the COMED tool, we'd be very pleased to hear from you. Also, the involvement of individuals attending this workshop on our volunteer register to get involved with different aspects of the ongoing improvement and development of the database. Your your volunteering would be gratefully received. So could I encourage you to please complete and return your feedback forms and send those completed feedback forms, including the section at the bottom on the areas of interest that to yourself that you'd be prepared to get involved with and make a contribution to. If you could return those feedback forms to myself at the email address shown on the screen, I'd be very grateful. If you could do that by the end of the week, while striking while the iron is hot, that would be best. So all that remains is to thank you all for giving up your time this morning and for your participation. I hope you've enjoyed the workshop. And I'll hand back over now to Helen or Alex.
Yeah, thanks, Andy. I think it's Alex here. I think I'll just close the session then. Well, I'm sure you'd all like to give a virtual round of applause to Andy and Mike for a very interesting presentation, and very brave as well. All the sort of workshop side of things and the technology and everything, which seemed to go reasonably well. Obviously, a few glitches, as you might expect, but yeah, certainly. I know Andy and Mike, or Andy in particular, has been on with this project for quite a long time now. He was, I think, talking to me about it several years ago. Was it 2015 when it first started or something? So it's been a bit of a journey, and still a bit of a journey to come. And I think, as Andy said, they're still looking for people to get involved, because I think it's only going to be as good as the amount of input and data that goes into it. So thanks again for joining, and I think sort of, watch this space in terms of how this COMED system develops. Okay, so it remains just for me to mention future meetings. We've got no immediate plans for any future London and South East regional meetings, but if anyone's got any ideas, please let us know. We're always keen to hear what's of interest to people. I mean, we will get something out, I'm sure, in the next few months. But I say all ideas welcome. Also, I think these regional meetings are almost becoming more than regional now, because we're online. Literally anybody can join. So please look out for other meetings in other regions. Also, just good to mention that the Northeast region are looking for a regional coordinator. There's a vacancy there. So if anyone's interested, who's particularly in that location, is interested in volunteering for the Northeast regional coordinator's job, please contact BOHS head office, or speak to one of the existing regional coordinators, or Helen or myself, for example, and we can sort of tell you a little bit about what's involved. It's not too onerous, and it's a good opportunity to really get established and network and meet a lot of interesting people as well. Okay, anything else we need to say, Helen? I think we're pretty well done. So thanks again, Andy and Mike. Excellent.
You're welcome.
Excellent session, and look forward to another meeting in due course. Bye, everybody, for now. Cheers.